I'm going to go ahead and do something I like to call the system pre-check or a system pre-test. Just as if I was about to run a customer support on someone's machine locally. This is sort of kind of what I would do to start things off. The first thing I would do is I would make sure my control box is off. And the first thing I want to see is if there's motion and there's no catching or binding in this motion here. Same thing with the y-axis. We want to make sure that there's no binding in this motion. Other thing I would do in this case, but I won't do on right now, is I would actually pull this completely off the rail and make sure that it is in fact square, and there's a video on the customer portal that shows you how to make sure it's square, but we make sure that all of our table is square. We do our quick measurements across. Once we've thoroughly tested with the machine off, we turn our machine on, and in this case we should be able to grab here and there should be no motion. There should be no motion here. And that means that all of the motors are successfully communicating with the control box and everything is locked down. If you experience any motion, it could be either a set screw on the back that may not be tightened all the way or that has worked itself loose over time, or it just could be a faulty motor wire. That's the other thing we will check, is we do check all of the bases of the connections. We make sure that there is no visible marking or damage on the wires, and if they aren't locking up properly, then that's likely going to be your first cause. We make sure all of our wires are all set. We make sure that every wire on this side is properly connected. In this case, these two motor wires here, my X and Z, need to be tightened. It looks like my A and Y are correct. My USB is plugged in. Now what I'll likely do, not in this case, but we'd unplug these, replug these in, and tighten them to make sure that they have a proper and accurate connection. The next thing we do is we check our air pressure. On our system, we have a small regulator here. It's sitting in around 110. We make sure that our box is on. We don't have any other warning lights. On the 65, we would have a warning light here or a warning code here if anything was wrong. We also make sure that our CPC port is properly plugged in and secured against the box so that we have proper connection for our control box to control this. We also want to make sure that our air compressor is on. In this case, we have a switch over here. Our compressor is on. We make sure that all of our gear track has no particulates, no crust developing on the inside of each of these. Make sure that you have no pieces of metal, no shards that could quite possibly hurt your axis travel. We check our gears underneath. We make sure that they're sitting properly and tight up against there. We don't want any gear slop. Gear slop will cause inaccuracies, especially when you're trying to do circles and or squares. They tend to be out of square, so we watch out for that. We make sure that up here we have our set screws properly tightened. You should see no set screw actually exposed out here on this particular part. What we also do is we make sure that when we lift this head here, we get motion, and we should hear an audible click at that little micro switch. One way to test that is we go into Diagnostic Alt 7 on Mach 3, and there's a button called Digitize. Now what I want to do is I want to lift up the Z-axis head, and that light should come on, and that looks good. Enable 1 and output 6. Output 6 is blinking, enable 1 is on, that's good. Our reset button is green and it's good to go. We have nothing in our dialog here outside of what's ready to run. Our G code is full. It's not an abbreviated G code from some problem that could have been present in the computer. We also make sure that your plasma wire is also okay. We double check our consumables down here, make sure we have new consumables so that we're removing that as a variable. So we just make sure that this system is cleared overnight. The other part that we actually check here is once we have our system up and running, we hit our up button to make sure that with the gantry facing us, it moves along the table that direction. We also make sure that when we're hitting down, it moves towards us. When we hit left, it should go left, and when it hits right, it should go right. And that's, of course, with the torch head and the torch facing you. You want to make sure that that's the case. We have a lot of different customers setting it at various locations, but wherever the torch head is based in terms of the front of the torch head is your 0 point or your front side of this. So if we push forward, it goes forward. When it pulls back, it pulls back. When we hit page up, Z-axis should go up. When we hit page down, the Z-axis should go down. If either of these aren't set properly, we have a video that shows you how to just switch that direction. One last thing we do before we actually fire up the machine is we make sure we hit F5, the F5 button right here. By hitting F5, it manually triggers that hypertherm to turn on the system. Hitting it once turns it on, hitting it again turns it off. And this just makes sure that the wire connection that runs from our control box to the plasma cutter is complete, and it's actually triggering the firing mechanism. That being said, after we've run those series of tests, we go ahead and zero everything out and start our first cut. But that's how we do a system pretest.